Hello and welcome back for lesson 9.5. We're going to be testing the difference between two proportions. And there's going to be a program in Desmos that we're going to use for that. And it's in your packet, and it looks like this. And the Desmos program is going to be for two proportions, and it looks like this. And so there's our requirements, similar to what we've been using. And here, how we're going to write our hypothesis statements. Proportion 1 is either not equal to proportion 2, proportion 1 is less than proportion 2, or proportion 1 is greater than proportion 2. We're only going to use Desmos, the calculator, so don't worry about this Z formula. We're going to get the Z and just write it in. And then we're going to either use the classical danger zone approach or the p-value approach. Okay, so let's go ahead and jump in with example 1. And the printout is not great. I'm going to copy here. So it says the General Social Survey tracks trends in American society through annual surveys. Married respondents were asked to characterize their feelings about being married. A researcher wants to test whether the proportion of males who report being very happily married is larger than the proportion of females. Sample 1 was married females, sample 2 was married males. Note these groups were not married to each other, so they're independent. Okay, the hypothesis test output for two computer programs are below. So we have StatCrunch output in Minitab. And you can see that we think that the difference is going to be less than 0 because we think that P1 is going to be less than P2. And P1 is the females is less than males, or the males is larger than the females. Okay, so remember that sample 1 is the females and sample 2 is the males. X is the number that said that they were happily married, and N is the total sample for each. And then we're going to put those numbers into the computer program, and we're going to validate what these two programs came up with. Here is the Z statistic, the Z0. Remember, the Z stat is the Z0 from our data, and here is the p-value, and they're always similar. It looks like this one is just rounded. So A says, explain why the researcher wants to test these hypotheses. And that's because they believe females are less happily married than males. P1, the difference would be negative because females are less than males. And that's why they're related in this way. How many married females were surveyed? And that was 423. How many married females reported being very happy? And that was 257. Find P hat 1 for the females. And that is 257 divided by 423, which is, let's just really good. All the way to the bottom here. That proportion is 0.608. And then it says how many people were married, how many married people were surveyed. And so that is our total. And that was 423 plus 366, which is 789 total. Compute the sample proportion difference. So we have 0.608 subtracting the males, and that difference comes out to be 0.608. Look at that. I just want to make sure here. Theirs is 242 divided by 366. So their difference is 0.661. So the difference is 0.0535. And then it says, state the test statistic, circle it in each output. So that's the output. And my test statistic is right here. It's a negative 1.558. And it's right here is a negative 1.56. And then state the p-value and box it in. And so there's my p-value on both of those. 0.0596 and rounded to be 0.06. And this is a left-tailed test. We can see that from our left band. So it's going to be shaded over here. And the p-value is 0.06. And I am going to compare that to our alpha of 0.05 right here. Down in J, they're asking us. I just kind of did it all in one step, which is greater than, so we do not reject H0. My p-value is here. Would this be statistically significant? No, because we do not reject. If the researcher set of it 0.05, what conclusion would be reached? And that would be there is not sufficient evidence to support the claim that males are more happily married than females. If the decision made above is incorrect, what type of error would this be? So we do not reject H0, so that means it would be a type 2. Type 2 is do not reject H0 when H0 is false. Good example. It says, researchers from the Pew Forum on Religion and Public Life interviewed 2 random samples of people. Both samples had 1,500 people. In 2002, 645 people expressed support for stem cell research. In 2009, 870 expressed support. So let's find the p-hat. So that is 645 divided by 1,500. And this is 870 divided by 1,500. At most. And so in 2002, it was 0.43, and 2009, it was 0.58. So we're going to see if that's a significant change. So this is the program that we're using. And Okay. So we're going to put in our 1500. So this example here, it on the program is for two proportions is what you'll find it as in Desmos. It's going to be labeled as two proportion z-test. And we're going to put in our n. You'll see that these are going to be closed up probably when you open it up. So you're going to click on group 1 and put in your sample size. And then the x1, which was 645. And I'm going to open up my group 2 and put in my sample size of 1500 and my X for group 2, which was 870. And then we have to decide what our hypothesis is. So let's go back to our paper and make sure that we have our hypothesis all set up correctly. So they're thinking that it's increased. It says perform a hypothesis test that the proportion of people who support stem cell research has changed. So it's just not equal to 0. So we're doing a two-tailed test here. So H0 is P1 equals P2, and HA is P1 does not equal P2. And this is our first two-tailed for all of chapter 9 so far that we've done. They want us to test at 1%, so that's 0.01. And then our test statistic is going to be a Z0. And then we are going to compare our p-value to our alpha of 0.01. Okay, so we're going to go back to our program there and look at the two-tailed test. So there's a right-tailed, the left-tailed, and the two-tailed drop down. And then we're going to go down to where it gives our p-value. Which is quite small. And you can see if you go down to the extras, that's going to give you, if you go down, it's going to give you your Z statistic. And our Z statistic is very large in the negative direction. So it's going to be, I just want to make sure I put in my X's correctly. Yeah. And that's why it's very, very, very small. So I'm just going to write here that it's very small because it's times 10 to the negative 16. Make sure when it appears that it's bigger than 1, a p-value is never bigger than 1. So you want to make sure that you're going to put that it's less than 0. It's not less than 0, but it's very, very, very close to 0. So we're just going to put our p-value is close to 0. So it's definitely small. We can also, like I said, go down. You're going to have to open up this extras down here at the bottom and then scroll down to the Z where it says Z right here. And there is our test statistic, which is a negative 8.216. It's most definitely in the danger zone for this problem here. So it's definitely less than. So we do reject H0. So there is sufficient evidence to support the claim that the people have increased support for stem cell research. Let's look at another. Let's look at example 4. I'm going to leave example 3 and example 5 and 6 for the extra video that is just going to be a supplement. So let's look at example 4. It says a random survey of 80 women who were victims of violence found that 24 were attacked by relatives. A random survey of 50 men found that 6 were attacked by relatives. At alpha point 10, can it be shown that the percentage of women who were attacked by relatives is greater than the percentage of men? So our hypothesis is going to be P, I'm going to say P women is equal to P men. I'm going to use W and M just to keep them straight. And they're proposing that PW is greater than P men. So let's just write out what we have here for women and men. And we're going to put this into the program. So for women, our X is 24 and N is 80. And for men, X was 6 and N is 50. So let's go ahead to our program. It's going to be called two proportion z-test. So our N for group 1, we said was 80 and 24. And then group 2 is 50 and 6. And this time we're testing a greater than test. We're going to click on this one. There is our p-value. Is 0.0089. And then again, I'm just going to go down here and click on my extras and scroll down to my Z and get my critical Z, or my test statistic, I mean, is my Z is 2.37. I'm going to round that to. So again, here's our p-value, 0.0089. So our test statistic is 2.37. We're testing at the 0.10. So we have a high threshold. Or it can be pretty high and still reject a 0. The picture here is a right tail, so we're shading over here. And our test statistic is 2.37. And our p-value is 0.0089, which is definitely less than alpha. So we do reject H0. So there is sufficient evidence to conclude that the percent of women attacked by relative is higher than percent of men. And either way, no one should be attacked by a relative. That is something that is a heartbreaking situation to think of. So please catch me back if you would like to see the examples for example 3, 5, and 6 for the extra video that is not recorded, but you can catch me back for that. Have a great day.